Alright, now I'm going to give you some examples of how you can move around the square so you really get an idea of how this works. Now I recommend, if you can make, here, if you can see that, there's what I had on the, one of the handouts that you got to get on the video. Make yourself up one of these. Make yourself up a cheat sheet, okay? It might be good to go grab one of those, or maybe you've already done that and you can look at this. So here's what we're going to do. How do we move around the square? And I think this is the way you're going to see how kind of nifty this is. And then I'm going to go over a couple examples, exercises in the book, because I'll bring up that Boolean modern / Aristotelian distinction a little bit more so you see how this works. Okay? Let's say we're starting with all cats are animals. Okay? And this is all because of Aristotle's square of opposition. You'd be amazed at what you can come up with. All cats are animals is true. Now that's an A proposition, right? So if we know that is true, we will be able to go around the square and determine what these other ones are. Now if all cats are animals is true, the E would be real easy. No cats are animals, right? That's the E. You remember, same terms, be consistent. The I would be some cats are animals. And then the O would be some cats are not animals. Okay, so what you do when you go around the square, if you know all cats are animals is true, so if we went to our square right here, okay, and we had up here, all cats are animals, right? And over here would be no cats are animals. I'm abbreviating, which is nice. We can just go fast. Actually, you know what? Let me put this in a different color here. Let's go with the red. Okay, I'll just, there you go. Well, let's do this. I'll stay with the blue and we'll, over here would be some cats are animals, and over here would be some cats are not animals. We'll get the red and we'll circle that. Over here, circle that, and circle that. Okay. Alright, now you remember from there the A proposition was true. And if you remember that, they're trying to ask you, do you know what the E, I, and O are? So if A is true, we can find out what O is by the contradictory relationship. If A is true, and you should have a little cheat sheet here. If A is true, then down there it's always going to be false, right? If every single cat is an animal is true, then to say there's at least one cat that's not an animal, that's going to be false. So if A is true, the E proposition becomes false. Now look at subalteration. If the O proposition is false, falsity bubbles up from hell, right? So we know E is false. And we can even know E is false. There's different ways you can do this. We know what O is by a contradictory relationship. If you start with A being true, O is going to be false. If O is false, through subalteration, we know what E is. But you can also get E from going this way. If all C or A is true, remember, if A is true, E's got to be false. And it is. You can get it by the contrary relationship or subalteration. If E is false, what does that make I with the contradictory relationship? True. But we could get it this way. If A is true, truth floats down from the heavenlies, right? So that would be true. So what we would do, if we go back to this page, and we come down here, we would know what to write in. A lot of your homework in exercise 4.5, exercise 4.5, section 1, that's what those problems all are doing, okay? So if you start with true, E is going to be false, okay? some cats are animals is going to be true, and some cats are not animals, that's going to be false. Okay, you can find the value of all these because you moved around Aristotle's square. Kind of nifty, huh? Okay, now let's do it this way. What if you're coming down here and you start with all cats are animals, but it's false. So the E would be, you know, just like we did before, we'd fill in these figures, they'd all go here. But if A is false, what do we get with the square of opposition? So let's go back to this. And let me erase these values here. Okay, we'll erase that. We'll erase this here. We'll come here, erase that. And we'll erase this. Okay. Now, it's false. Okay? If the A proposition is false, Aristotle's square of opposition tells us that the O proposition will be true. Always use the contradictories first, because you will always get something there. Okay, so this is true here. Can we know what E is through subalteration? No, because that's undetermined, right? Falsity bubbles up from hell, remember, but truth does not go up, and I gave you some examples on the previous video. So we can't get E from this. Okay, well maybe we can get E from the contrary relationship. If A is false though, remember with your little cheat arrows, this is undetermined. We don't know what that is either. Okay, what about if this is false, we can maybe get I down here. Well, if this is false, falsity doesn't float down from the heavenlies. So we can't know that either. All we know is the A proposition is false. All we can get is the O proposition is true, but E and I will be undetermined. So if we go back and come down, you're going to have this. You're going to have the E proposition is undetermined because we don't know. The I proposition is undetermined. We don't know. The O proposition we do know is going to be true. Okay, and that's moving from the square. So when you get to exercises 4 or 5, section 1, that's all you're doing there. Now, I do want to talk about how to do the problems in exercise 4 or 5, section 2. Okay, listen carefully, and I'm over here. I'm going to explain Aristotle's his existential import and the modern Boolean, Boolean, it's just two ways to describe it, versus Aristotelian will come into play on this one here. Okay, so you need to know this because you need to know this for your homework sets and stuff like that. So let's just do this one up here first. And why don't I use green here just to separate stuff out. Okay. Here's what number 1 says in exercise 4 or 5. And you remember what these are telling you to do is use the traditional square of opposition to determine whether the following immediate inferences are valid or invalid, and name any fallacies that are committed. Okay, you remember an immediate inference is a quick argument. It's one premise, and from that one premise you can come to a conclusion. Aristotle's square of opposition is about immediate inferences. And so, is this valid? If you know that all advocates of school prayer are individuals who insist on imposing their views on others, if that's true, and if it doesn't say it's false in these problems, that means it's true. And what is this? Is this an A, E, I, or O? All advocates of school prayer, that's the S, are individuals who insist on imposing their views on others, that's the predicate. That is an all S or P, right? All S or P. So this is an A statement. So we know that the A statement is true. Okay? If you know that the A statement is true, then does this follow? And this says some advocates of school prayer are individuals who insist on imposing their views on others. Okay, what is this? We have the sum, we have, this is the S, we have the copula, and this is the P. So this is a sum SRP. This is an I proposition, and it's not saying it's false. So it's saying I is true. So basically what you have here, everybody, is you have an A proposition that's true. And you remember these problems, if it doesn't say it's false, it means it's true. If you know the A is true, can you conclude that the I proposition is true? So if we go to our little square of opposition, and let me just erase those things here so that doesn't confuse you. Okay, we'll get this all erased here. Let me go a little bigger. Okay, come down here. Erase that. Erase this. Okay, we're back in business. So, if we know that A proposition that we just went over, let's go back real quick. All advocates of school prayer are individuals who insist on imposing their views on others. If that's true, does it follow, so the A is true, does it follow that some individuals who, whatever that said, let's go back, does it follow that some advocates of school prayer are individuals who insist? So if all advocates are true, the A is true, does this follow? Is this true? And this is subalteration. And on the Aristotelian square of opposition, if the A proposition is true, it follows that the I proposition is. So when you come back to this, you would say that this is valid. It's a valid immediate inference. Okay? When it's invalid is when after you identify it's an A, E, I, or O, let's say it said that this was false. Then you'd say it's invalid because if it's false, you don't know if the I would be true. But here, you just simplify that. That's an A proposition. It is true. If A is true, this is an I proposition. It's true. If A is true, can you know the I is true through subalteration? Yes, you can. So it's valid. There are no fallacies. A fallacy is when you do something and you're not allowed to do that on Aristotle's square of opposition. So if this was false and that was true, this would be called illicit subalteration because you can't do that. So anytime you go in a direction where it's undetermined, then the fallacy is you call it illicit subalteration. Or if this was false and you thought the argument said this was true, you'd call this illicit contrary. Okay, stuff like that. Okay, let's go to the other one because this one's important too. This is in section 4.5, Roman numeral 2, but this is number 4. And here's what this says. It is false that some trolls are not creatures that live under bridges. So what you have is you have some trolls, that's the subject, are not creatures that live under bridges, right? So you have some S are not P. So this is an O proposition. You look at it and you go O, and it's saying O is false. Then you look at this. It says it's false again. No trolls are, and there's the predicate. This is a no SRP. And it says that this is false. So really what it's saying is you have an E proposition is false. Well, no, you have a O, you have a particular, it's false, and then the E is false. So if we go to the square of opposition, here's the O. It says O is false, right there, false, and falsity does bubble up, right? So E would be false. So here's the thing. The move is valid. Okay, so, but here's the thing. With Aristotle, remember, he only wants to talk about things that refer to things in the real world. So, this immediate inference, the only problem is, it's talking about trolls. trolls do not exist. So Aristotle's not going to like doing this. So here's what you have to do with 452 number 4. You're going to notice in the back of your book, it's going to say existential fallacy. Okay? What this means is anytime with Aristotle, if you can make the inference, like if it's falsity going up, or if this was true and it said that was false, everything is fine. But with Aristotle, when falsity bubbles up, initially that troll arc immediate inference looked good. You have to say this. You have to say, with Aristotle, it's conditionally valid. And the condition is, this is a valid move as long as the terms are talking about things that really exist. So it's conditionally valid, meaning you have another step. Do the things exist? Okay? And with Aristotle, trolls do not exist. So even though it's conditionally valid, because falsity bubbles up, you guys saw that. You might say in the beginning, valid, it's a good immediate inference. Aristotle goes, oh, no you don't. It's conditionally valid. In a sense, when you go around the square with Aristotle's square of opposition, everything is conditionally valid if it works. You just have a quick second test. Double check to see if it's talking about real things. So everything we essentially have been doing have all been conditionally valid, but it's been talking about horses and four-legged animals and all this, so it's a valid. I haven't really had to bring that up. But here, falsity does go up. It's conditionally valid. But do the things exist? Trolls do not exist. So what you have to say for this thing is it's invalid. Okay, you're going to say invalid. And the reason is the existential fallacy. Okay? So with Aristotle, you're going to say existential fallacy. And then it's conditionally valid, but if it's talking about things like trolls, they don't exist, Aristotle says, no, I don't like it. We don't make logical inferences about imaginary things. So your answer should be invalid, existential fallacy, and you're going to see that in the back of the book. And I would expect you to know this because that'll be some kind of an answer you possibly need to know when you submit your set number 3 answers and your test number 3 answers. Okay? So I hope that really helps. So you need to know that about this. And just remember with Aristotle, if you say some horses are four-legged animals, you know, all horses are four-legged animals, you are allowed, and that's true, then it's also true that some horses are four-legged animals, because four-legged animals exist, right? So we know they exist. If all of them are four-legged and a Martian knows at least here's empty, then if all are four-legged and horses exist, then at least one is four-legged, and that's going to be true as well, okay? Because these things exist. Remember, a Martian's going to go, no, we don't know that exists, you know, so we can't do that, but with Aristotle we can, you know, so we'd erase that, okay? So I'm getting kind of redundant, but hopefully this helps, and if you've watched these 3 videos, you have an idea of what I only want you to be concerned with up to this point on the modern or Boolean versus the Aristotelian distinctions. Okay, our next video is going to be on translating ordinary categorical propositions. Translating ordinary statements into one of the 4 categorical propositions, and you'll find that very, very relevant stuff. Okay.